Hello everyone. Today I want to walk you through the Jira to Harness IaCM integration that I have built to standardize and govern infrastructure provisioning process. The core idea behind this solution is simple. Instead of treating infrastructure provisioning as a manual, ticket-driven operational activity, we treat it as a controlled policy-driven platform capability. Today, we face several operational challenges while implementing IaCM at scale. This includes manual infrastructure provisioning, lack of standardized tagging, no centralized policy enforcement, security and compliance gaps, cost overruns due to approval gaps, increased attack surface. From a business perspective, this results in delayed provisioning cycles, shadow IT risks, untracked cloud spend, and governance drift. These issues impact both operational efficiency and financial accountability. Our vision is to treat infrastructure as a product. This means enabling self service infrastructure for application teams, implementing policy driven guardrails, ensuring cost aware provisioning, supporting one pipeline across multiple workspaces, and maintaining full auditability through Jira. The goal is to provide speed to engineering teams while maintaining governance, compliance, and cost control. The process starts when a user creates a Jira ticket. The ticket captures all required infrastructure details such as environment, resource type, sizing, tags, cost center, and approvals. A Jira webhook then sends this ticket information as a structured payload to Harness. This ensures the request is standardized and machine readable from the beginning. Once the webhook is received, Harness triggers a workspace creation job. Based on the ticket metadata, a dedicated workspace is provisioned. This enables environment isolation while still using a single standardized pipeline. It also ensures traceability between the Jira ticket and the infrastructure workspace. Before any infrastructure is deployed, policy validation is enforced. We use Open Policy Agent for governance rules and Checkov for security and compliance checks. This stage ensures guardrails are applied before execution, not after the deployment. Once validations pass, Terraform and OpenTofu executes the apply stage and the infrastructure is provisioned in the cloud. All changes are version controlled and auditable. To summarize, Jira acts as the control entry point, Harness orchestrates automation, policy engines enforce governance, and Terraform or OpenTofu deploys the infrastructure, and everything remains fully traceable. This enables self service provisioning while maintaining compliance, cost visibility, and operational control. Now, let us walk through the demo. First, the user will create the service request. Here, in this case, I am creating a EC2 instance. So, I am selecting the EC2 for dynamic website template. Now I'm filling out the details of the form. I can select the instance type. I can fill in the owner, cost center, and environment. And let us create the ticket. Once the ticket is created, we need to move this ticket to in progress to initiate the webhook. So this will trigger the webhook. Now let us go back to the Harness pipeline and we can see a new pipeline job has been initiated. Now let me show you the pipeline a little bit. It consists of two stages. First is to create the workspace. Here we will use all the variables that we are getting from the payload to create the payload which we will use to call the Harness API to create the workspace. And once the workspace is created, we will export the workspace ID from this stage so that workspace can be used in next stages. Here you can see I have used the input and output variables for this purpose. Now if we go into the Terraform apply phase, we can see that we can also add a Checkov test over here. We will keep the configuration as default, but let me just select fail on severity low to show you how the pipeline will fail if the conditions are not met. Now let me also show you the trigger. These are all the variables that we have used in the trigger. Here you need to input all the values from the payload. So I will show you in detail how to do that, but first let us go through the pipeline. As we can see, the workspace is already created and also the Terraform phases has also started, and currently the pipeline is waiting at the Checkov scan, and we are expecting it to fail, and yeah, it has failed because the threshold was given as low. So if any condition is not met, the pipeline will fail. If it is set to high or critical or none, so in that case, if only critical conditions are not met or if only the high conditions are not met, then only it will fail. So soon we will change it to none, so the pipeline will not fail even if the policies are breached, but that is not a good practice, but yeah, just for the demonstration purpose. We can also use the analyze error AI feature that has been included in Harness new versions, and it will go through the logs of the past execution and the current execution, and it will show you why this execution has failed. So let us wait for it to process, and then I will show you the results. As you can see, the Harness AI is suggesting what to do in the pipeline in order to get rid of this error. So I must say that this is a very efficient tool in quick debugging of your failed pipelines, and you can use it for this purpose. So let us now edit the pipeline to and change the fail on severity to none so that our pipeline goes throughout the process. Then we will rerun the pipeline just to see how it works. In order to re-trigger the job, we will change the status of the Jira ticket from in progress to pending and again back to in progress. So the automation will trigger this pipeline only when the Jira ticket is moved to in progress state. So as we can see, the pipeline is again triggered by the Jira ticket. So as the checkoff phase is running, let me show you how the cost calculation actually works in the pipeline. The cost for provisioning the instance is being displayed during the plan phase itself. So further in automation, we can do in such a way that approval can be triggered by looking at the cost, and only if the cost is allowed, then only the infrastructure will be provisioned. Now, as we can see that Checkov scanning is also complete and it has passed the Checkov scan. And now if we check in cloud, the infrastructure is also provisioned and also the tags and everything is populated in the infrastructure. Also in the executed pipeline, if we go into the policy evaluations, we can see how many OPA policies were evaluated. And if we click on the resources, we can see what resources were provisioned. The ISM cost change estimation will also show you how much cost is increased after deploying the infrastructure. Also, if you want to track that particular workspace, you can put in the Jira ticket number and it will show you which workspace was created by which Jira ticket. So in summary, this enables a model where users initiate provisioning via Jira ticket and Harness IaCM automatically executes the required Terraform code from GitHub to provision infrastructure end to end. So now let me quickly show you how to configure this. First of all, you have to create a separate Jira space, which I have created. And in that space, you can create several service requests. Generally, the service request types will not be available, so you have to create from scratch. As you can see, I have created EC2 for dynamic website and S3. Now you can add the fields, the required fields which you think is going to be needed by that particular request type. I have filled the necessary fields for the EC2 creation service request type. In your case, you might need some more additional fields. So in that case, you have to go to the settings and add fields inside Jira itself. So I will show you for the instance type how I have configured the field type. As you can see that I've used a list and all the T2 family and M5 family I have put as a fixed list. You can add it to whatever values you want and then you need to add it to a screen. So in our case, it will be Jira Service Management, Request Fulfillment, Create Issue screen. But in your case, if it is some other screen, you need to find the screen and add those fields to that screen. Otherwise, the fields will not be visible. Once the fields are added, you need to come back to the space settings and add those fields again to the service requests. So once the service request types are created and all the necessary fields are added, we need to move ahead with the automation. So in order to create the Jira automation, you come back to the project settings and then you go to automation. And since we have two service request type, one is for EC2 and another one to create S3 buckets, we will need two automation. So depending on the service request types which you are creating in your project, you will have individual automations to trigger those pipelines in Harness. So as we can see that this particular automation rule has two. The first component is to check what is the status of the Jira ticket. In this case, when the status is moved to in progress, then this component will initiate the automation. And there is another condition to check whether the work item in this matches the EC2 for dynamic website. So here you can see that you can put different request types. If you have the S3, you can put in S3 as well. And based on this, the next step will be configured. And the next step, we are just putting the webhook URL of the pipeline over here and defining the HTTP method. And we are selecting the web request body. These are the available web request body, but you have to select a Jira format if you are comfortable with that. And then if you want some authorization tokens or anything, you can put it in the additional headers. I'm keeping it as blank for now, and that's it. So similarly, if you review the S3 rule, you will also see that the rule is similar, but the request type is different over here and the webhook URL is different. So in order to get the webhook URL, you need to create the pipeline first. Even if the pipeline doesn't work, it's fine. We just need to get the webhook URL. So now let's come back to the pipeline and validate the stages over here. As of now, we just need the trigger, but still I will tell you what are the details in the pipeline. So we create the first stage, which is to create the workspace, and then we add the Terraform apply phase where the actual infrastructure will be provisioned. So let us review the first shell script quickly. We are passing all the variables in this shell script, and these variables we are getting from the payload. So how we are configuring these variables? So in order to do that, you have to declare the variables over here. Once you declare the variables and put it as runtime input, you need to configure the trigger. So to create the trigger, you come to trigger and click on new trigger. And once you have done that, you will get something like this. Here you will get an option to put the values for the variables. But please note that you have to paste the actual path of those values from the payload itself. So while you are doing it, you might not have the actual fields. So I will show you a way how you can do it. So once you have created the trigger, you just copy the webhook URL from this trigger and you paste it inside the automation and update the automation. So next time, whenever you are creating the service request ticket, you pass in the values and you create the service request and you move that service request to in progress so that this automation can trigger a dummy request. And when Harness will receive that dummy request, it will show you in the activity history. So here was my first dummy request. It did not run the pipeline successfully, but it was triggered. And if I click on the payload, I can see all the custom fields and everything over here. So from here, you can refer what values to give inside the trigger variables. So this step is a little bit complicated to understand, but once you are going ahead with the automation, you can do it very easily. So once you have configured the trigger properly, you are mostly done with the automation. You just need one additional step right now. So if the pipeline is triggered once, even if it doesn't run, what will happen? If you look at the output values from the first step, you will see what was the workspace ID. So in my case, the workspace ID was created, but what I need is the exact path of the workspace ID in Harness. So once I get it, I just copy it from here and we need to pass this in the next stages. So I'll move on to the Terraform apply. I go into the input and paste that path over here. There is no drop down box or anything, but you will get, if you just paste it over here, it will accept the Terraform path over here. It will make sure that whatever Terraform apply is being run, it is running on the workspace ID that was created in the preceding steps. So that's it. Once you have configured the automation, you just create a actual request and you can see the pipeline running. And if everything is successful, you will see all green over here. With that, we can conclude this demo and revisit what this solution is providing. This solution enables self-service infrastructure, transforms infrastructure into a product, integrates security and cost controls, reduces risk and complexity, enables scalable enterprise growth, and strengthens platform engineering maturity. All the project files and the detailed implementation steps are stored in a GitHub repository. Just look into the description. I will update the description with that repository link.